In this section, we are going to do more work with the normal distribution in the table, except now we're going to adapt it to real-life situations. So I'm going to show you some of the problems and styles of things that we do in terms of setting them up. There will be a way that you'll become comfortable with after you've done several of them in a row. So let's start first of all with getting the shadings from a real-life situation to the standard normal distribution table. Okay, here's the first problem. Let's start with A, and it tells us that we want to find basically the area to the left of z equals negative 0.86. So let me get a picture of this situation. So we're talking about the standard normal distribution. So 0 is the mean that's under the hump. And we want the numbers to the left of z equals negative 0.86. You'll recall this axis is called the z-axis. So over here to the left of 0, I have negative 0.86. Now we want the area to the left of it. So draw a vertical line till you strike the curve. And you're either always going to shade to the left of it or to the right of it. In this case, we want less than. So that's to the left. That's in here. And now what we do is we go to the normal distribution table and try to figure out what the area of this shaded region is. And that is exactly what they're looking for. All right, I've brought out the relevant section of the table. So I'm going to go along the negative 0.8 row. There's my row. And then this is my column. So I have negative 0.86 there. So I'll go across here and down here. There's our guy, 0.19489. Now, it's also possible you may be asked to put it in a percentage format. If you had to do that, you can also write this as an answer. Just move the decimal 2 places to the right to get the percentage. The next on the list was greater than negative 0.86. Now for part B, they wanted greater than that same number. So I'm going to try to make it look just like it was up there. When I put the 0, it's just a reminder to myself that I'm dealing with the standard normal distribution. Greater than is going to be this. Now in the previous problem, we've got the answer. It's right here. This piece right here, this area in here, is going to be 1 minus that answer. So we're going to have 1 minus 0.19489. And I'll just grab it with the calculator. Uh, 0.80511. And that completes that problem. If I scroll up, they give you a lot of the same ones here. I'm going to have the same style of problems, C and D, but less than and greater than 1.34. They probably chose those because they're on the other side of 0. So 1.34, I'll have to keep track of that. So they want Z to be less than 1.34. So 1.34 is going to be on the right side. And the table is structured in such a way that I can look up 1.34 on the table. Here is the relevant portion of the table. So I'm looking at 1.34. So So let's see what I have in this spot here. 0.90988. So that's directly from the table. That is that area right there. Of course, as a percent, you'll have 90.988%. Then part D was the same problem, but we were going on the other side. We were looking for Z greater than 1.34. So it looks like the one up there, except it's shaded in opposite fashion. Greater means to the right. And now since we know this area in here, to get the shaded area, I will subtract that number from 1. (0.09012). Let's go back to E and see what it was asking us. Greater than Z equals negative 2.88. So that'll be to the right of negative 2.88. So we want greater than, that means we want to the right. Now the way you can work the table is this. You can look up this area, this little white area in here, using the table directly. Here's the relevant section of the table. I'm going to look at negative 2.88. Let's see what we have. Here to here. 0.00199. Okay. So the shaded region, then, I will just subtract that number from 1. Now we have a different style of problems to work. These are problems between two Z values. So let me start with A. Here, when they put between Z equals 0 and Z equals 0.47, we can actually write this. Z I'm going to have in between 0 and 0.47. That's the area that's going to be shaded. Let me draw my picture. So this is the band that we're going to be looking for. Now the way this works is I'm going to do this in a slightly, not backwards way, but it's not exactly the thing you'd think of right off the bat. What I'm going to do is find the area of this white region, and I can use that. Well, 0 is really easy. You don't need the table to know that half of the data is in half of the graph. But over here, how do I get this area in here? Well, the table doesn't work from 0.47 off to the right. However, if you'll remember, this is the same amount as this. I'm going to just do it real quick. This will have the same area if you just go to the table and look up negative 0.47. Here's the relevant section of table. Here's 0.4. There's our 7. We'll go along here and along here, and we get, there's a mistake. I'm actually glad I'm doing it. I said you should look up negative 0.47. So I'll tell you how I knew where I made my mistake right here. Let me write the answer, what I was going to put, and then you can see if you can tell if there's something wrong there. See, this little white area here is only inside of 1/2 of the graph. That means it must contain less than 50% of the data. This is over 68% of the data, so you know it can't be correct. Now I have the relevant table data. So I'll start at negative 0.4. There's my 7. I go across to there, and there's our guy there. That looks more reasonable. 0.31918. And then the shading in the middle, I will simply take 1, which is the area under the entire curve. I will subtract off the 50%, that is the right half. And then I will subtract off the 0.31918, which is this little piece in here. What's left over will be this shaded region. So the area left over is a little over 18%. For part B, we're between negative 0.3 and 0. So this one will be a little bit on the left side. I'll make it a little bit bigger than it probably is. Once again, we have an easy area over here. We're shading between two things. So I need to go look up the table at negative 0.3. Lucky for me, I noticed that it's right here. So I'm going to take these ones out. And a negative 0.3 is actually right in this spot here. That makes sense. 38, that looks like it could be about 38%. So that area found from the table, 0.38209. And then this piece here, I'll take 1 minus 0.38209 minus 0.5, which is the 50%. Little less than 12%. Next, we're doing z between negative 0.3 and z equals 0.47. And let's draw a picture of this. Now from the last problem, we already did this piece in here. I'll get 0.38209 for that. I think we did this in one of the first problems. Let me see if the 47 was the first one we did. Well, we didn't actually do it, but we did find this out here. This is the area, the 31918. So that's this area here. 31918. And then to get the stuff in the middle, as with all the other problems, we'll do 1 minus 0.38209 minus 0.31918. And that'll give us our answer. Here I put the area inside of the location where it's actually at. there's several sections here. This is something that you need to get really good at, so that's why we're doing a lot of practice with it. So all A, B, and C were all interrelated with each other. D is a completely different problem, but we are between negative 2.24 and negative 0.55. And this is the shaded region for this one. This little white piece out here is very easy to look up. Just go and use the table on it directly. All right, negative 2.24. I have, here's negative 2.2. There's my 4. So we have 0.01255. And then I need this piece out here as well. There's a lot of different ways you can do this. If you can look up, say, negative 0.55 in the table, and that'll give you the area of the shaded region all the way to the left. And then you could take 1 minus that to get this piece. Another thing you could do is the following. Just a quick, dirty little graph here. This shaded here, this is 0.55, by the way. This shading here is actually equal to this. You got to think about this as being reflected around the 0 line, I guess. But let me make that more clear. So I can use a table lookup for this. I would use up the positive values. Let me go ahead. And you can tell, you can see that it's going to be more than 50%. Just like here, you have more than 50% of the data. Here I've grabbed enough of the table to see what 0.55 is. There's 5. There's 0.55. And so let me go here, here. So 70.884%. So that's the area of that white region there. Then if I went the shaded region, let's do it over here. I'm going to do 1 minus this piece. And then I'm going to subtract off this piece as well. And that finishes off that one. Let's go back and look at E. What was E? Between 1.46 and 2.37. That was this D? That was E, okay. Here's our situation. Now, to get this white area here, you can just look up 1.46 in the table. Here's the relevant section of the table, 1.46. That's almost 93% of the data in there, 0.92785. And then this little piece In the table, you can look up negative 2.37 and get the exact answer. All right, I've tried to situate the relevant portion of the table with the other heading so that I didn't have to put a new heading in here. So I would like to look for negative 2.37. There's 3, and there's 7. So that little piece, 0.00889. And then the area in between, 1 minus 0.92785 minus 0.00889. And there's our final area. See, that little strip only had a little more than 6% of the data. And there's one last one, that's F. It's something of a symmetric problem. You'll see it when I show it to you. Here we have negative 1.5 is less than Z, which is less than 1.5. Drawing a picture. This is what I want. Once again, we can use the table to get this piece right here. And then when we get that piece, this area here is exactly the same as that area. So the two white spaces are of exactly the same area. Well, negative 1.5 is very easy to figure out. It's the first item in its row. So over here, I have 0.06681, and I told you that the area on that side is exactly the same. So then the amount in the middle, I'm going to take 1 minus. You can do 1 minus 0.06681 and then minus the other one, or you can do 1 minus 2 times 0.06681. Either way, you'll end up at the same answer. So we can see this middle section here has more than 86% of the data. Now, all of these problems were what we're going to need to do to solve the problems that we're really going to have to do. And they're all word problems, but we're going to use this to help us with every one of them. We'll just start. I'll write out the first one, and you'll see what I'm talking about. Here's an example of one of the problems that I'm talking about. Now, I'm going to show you a three-step process for doing each of these problems, and we're going to use the same process for the entire semester. First of all, I'm going to draw the real-life situation. That's step one. So what I do there, it's going to be a bell curve. They're all going to be bell curves because everything's going to be, you have to be told it's a normal distribution. And you can see that a heart rate for a normally distributed population of men. If you don't know that it's normally distributed, then you don't know that you're dealing with a bell curve. Now what they did here is they gave us the mean was 62. So under this highest point will be 62. The standard deviation, let me put the 62 for my mean. And the standard deviation was 11. They want the percent of men having under 70 beats per minute. Now 70 would be to the right of 62. Now since they want the heart rate under 70 beats per minute, we're talking about going to the left. Now, you cannot look this up in the table as it is. There's a second step that we need to do. I could probably have called this step 1, and then step 2, compute the z-score. I'll try to remind you of it. The z-score looks like this. Z equals x minus mu divided by sigma. The x we're talking about here is 70. You want the edge of the region. So 70, the mu was 62, and the sigma was 11. So this is 8 over 11. Now, we're going to be using the tables, but the tables only have 2 decimal places of accuracy in the margins. So I can't look up anything that has more than, my z-value can't have any more than 2 decimals. So with that said, this decimal is 0.727272. Let me write that down. And it goes on and on and on. So I need to round to 2 decimal places. So if I round to 2 decimal places, my z-value will equal 0.73. Now, third, draw a new picture. You're going to use the standard normal distribution. So this will be the one that I'm going to use the table with. So that's basically what we do. We transform the problem into one that we can handle. Now I'll just go to the table. All right, I have enough of the table to tell 0.7, there it is 0.73. Now, when you do look at your answer, make sure that it makes sense. It's clear that this shaded region has more than 50% of the data. So whatever value I get off this table had better be bigger than 50%. In fact, it's quite a bit bigger than 50%. The table gives us 0.76730. And that's the answer to the whole problem. You don't have to do anything more. So this is the basic idea. We take a real life problem, we transport it to the standard normal distribution table, then we get our answer. Part B is a companion to part A. Now we want 70 beats per minute, above 70 beats per minute. So let me go. This time we went to the right. Now, you don't need to do any more. I'll show you why. Let's go up to the other table here. Let me grab that. This one here, we've already done. That was the 0.76730. So this piece then, since the two of them combine total up to 100% of the data, I can get this piece by doing 1 minus 0.76730. So a little under 24% was that answer. There was one last piece. That was part C. Here we want people that have resting heart rates between 40 and 80 beats per minute. So between 40 and 80. First, draw a picture of the real life situation. Remember, the mean was 62. Here, 40, I don't know where it'd be, probably about here. So we want between those this shading. Now, since we have a left boundary and a right boundary here, I'm going to need more than one z-score. If you recall, the mean was 62 and the standard deviation was 11. So here we do a z-score for this guy. So that'll be z equals x minus mu over sigma. The x there is 40. The mu is 62 over 11. And I think you'll find this turns out to be -2. I need to do the same thing for this one. So I'm going to have 80 minus 62 divided by 11. This one won't come out as well. And remember to limit your answer to to 2 decimals. All right, let's start with 80 minus 62 and then divided by 11. So to 2 decimal places, I'm talking 1.64. Now I'm ready to draw a picture using the standard normal distribution, whose center is at 0. And we are going to use the table to get the numbers from this. This white space can be looked up directly in the table. Just look up -2 in the table. Here's the relevant section here. -2.0 is down here. Oh, I've almost cut it off, I think. That's 0.2275. Now to get this area up here, you can look up -1.64 in the table. Here I've added in the relevant section. I think I'm fairly lined up enough. I need -1.6 and then 4. So I'll come here and here to this guy, 0.0505. This last 0 that they have on there is completely unnecessary. You can use it or not. Then in here, I'm going to do like I have on all the other ones, 1 minus that stuff. Minus 0.0505. And you can see almost 93% of the data is in that range. Here's the next problem. We have the average height is 5 feet. That's 64 inches. So 64, that's mu. And a standard deviation of 2.8 inches, that's sigma. Now, at any time, I'm going to do a lot of these problems. If there's any time that you want to pause the video and try it on your own, do that. See if the sooner you get that, the better things will be, I'm sure. So let's start with A. I'm going to do my same process. But this time, this is the real life situation, so I'm putting in the mu that they give me. And 5 feet, 5 times 12 inches that equals 60 inches. So we want shorter than that. So let me put the 60 on here. That means I'm shading to the left of it. Next, if you'll recall, we needed a z-score. The x in this case is 60. The mu is 64. And delta is 2.8. So that means we have to do, I covered some of it, 60 minus 64, negative 4. And then I'm going to divide that by 2.8. So about negative 1.43. That's what I'm going to do. Remember, you have to round to only 2 decimal places to make this work out. Now, once you've done that, you've transformed the graph into one that looks like this. Notice the two graphs, they still look the same, just the numbers are different. I can take this value directly from the table. Here I've uncovered enough of the table to finish this problem out. Here's negative 1.4, here's 0.3. This is the guy I'm looking for. 0.763, I'm missing a decimal, 0.07636. And that takes care of the first question. So that's roughly 7.636%. I think I'll answer this one in percentages since I did the first one in decimals. Next, we're going with 6 feet, taller than 6 feet. So 64 inches. 6 feet, 6 times 12 is 72. So we're going to have 72 inches. And we want women that are taller than that. So I'm going to get a z-value. Z equals x minus mu over sigma. The x in this case is 72. The mu is 64. And sigma was 2.8, I believe. I'm going to have to go with 2.86 to 2 decimal places. So there's my area there. Now, what you can do is you can look up 2.86 directly in the table, and it will give you the area of this white region. Or what I prefer to do, I'm just going to look up negative 2.86 and use the symmetry. Okay, I've exposed enough of the table. Negative 2.86. So that area there, inside of there, is 0.00212. As a percentage, that number is 0.212%. So it's really tiny. Moving on to part C. Well, we want to know what percentage are between 5 and 6 feet. I won't need the table for this part. Let's draw a picture of the situation. $64 was there. Then we went down to 60. That was 5 feet. And then we went up to 72. And so we have the area in between them. Well, we've done the other two. We found the area here in the first part. Where was that area? That area was 7.636%. And this area we just found in the last one, that was 0.212%. Now, I am sort of violating my own covenant with you because this does not look like it's less than 1%. It looks like it's a lot bigger than that. So my picture could have been better. There's absolutely no question. But now that I have that settled, let me go ahead and figure out this percentage in here. So if you're going in percentage, you're going to have to subtract from 100%. And there we have over 92% of the data lies within those regions. Here's another situation. Here we have a mean of 270. There's my mu. And a standard deviation of 16 cars. There's sigma. Let's start with part A. Remember, write the real life situation first. So that means I'm going to have it centered at 270. When I draw my bell curve, I'm going to have 270 be in there. I'm just working on part A right now. We want less than 240 cars, so that would be under the average. Now notice what's going to happen here. I'm going to get a z-score for this, and so we want this shaded region. The z-score will be negative. Any x value that is less than the mean will have a negative z-score, and every x value that is above the mean will have a positive z-score. So let's go and get the z-score of that. So remember, z equals x minus mu over sigma. Let me go and put in my numbers. Mu was 270, x was 240, so 240 minus 270, and sigma was 16. I think this is negative 30 divided by 16. So I get negative 1.875. Oh, where should I put this? I should probably put this down over here. Seems more reasonable to put it down there because that's where that, ooh, what a lousy curve. Anyways, this is my standard normal distribution. I put negative 1.875 here, and I'm going to shade to the left of it. You can look this up directly in the table. Now remember, we can't go that many decimal places. 3 decimal places won't work. So I'm going to have to look up, take this thing here and round to negative 1.88. Because you only have 2 decimal places in this table. Very small amount. We have 0.03005, approximately. I think they wanted a percentage, so this equals 3.005%. Will be receiving this. I thought that was the bonus. No, these are the number of people that are well under the mean. Part B, more than 265 cars per day. So let me draw a picture for that. So they said more than 265. So remember, the original real life values are called x's. And let me catalog my mean and the standard deviation again because it's useful to have. Mean is 270 and standard deviation is 16. This is the situation indicated here. And as before, let's go get a z value for the boundary. So it's x minus mu divided by sigma. X was 265 minus 270, and sigma was 16. So we have negative 5 over 16 0.3125. But of course, since you're going to be using this on the table, you need to round. In this case, 2 decimal places is 0.31. I have made a mistake. It's negative. This is also negative. So we are talking about the area out here. Of course, that's 0. So I can use the table to give me this white area here. So going into negative 0.31, there's our guy. Of course, to get the shaded region, we subtract the number I just wrote down from 1. As a percentage, that will be 62.172%. Part C was the bonus for anybody that gets more than 310 of these things assembled in a day. So let's take a look at this. Draw a picture of the relevant situation. The mean was 270. The standard deviation was 16. And then so 310 is quite a ways over here. And so it's probably going to be a very small number. Considering the last number, well, the last number was kind of big. Let's do the z-score for it. X minus mu divided by sigma. X is the 310. Mu is 270, and sigma was 16. So we have 40 over 16. .5. So we're shading to the right. Draw a new picture of the standard normal distribution. And once again, 2 ways to do this. I could find the area of this white region simply by looking up 2.5 in the table, or I could look up negative 2.5 in the table because that little tail has the same area as this little tail. I will look up negative 2.5 in the table. So negative 2.5, that's this thing right here. As I figured, it's very small. 0.00621. As a percentage, that's 0.621%. Now, what we've done so far is you've had z values or x values, and from that you determined areas based on those values. There's a reversal of this that we also do. Sometimes I know the area, but I don't necessarily know the z or x values that are involved, and I'm asked to find those. Let me show you one that I'm talking about. All right, here's a problem that is exactly what I'm talking about here. First, let me draw a picture and explain what they're trying to get you to do. So in part A, you're trying to figure out the actual score that allows this to happen. So we know that the mean is 750. There's the mean. And the standard deviation is 50. The 90th percentile score is the score that is greater than 90% of the data. So what I'm going to have is this. If I put an X here, I don't know what it is. Let me go up here. They're talking that 90% will be inside of here. So the problem with this is you do not have, the table won't handle a situation like this. So what you have to do is you go and do your 90% on the standard normal table. So you're going to draw almost an identical picture, although mine doesn't look nearly identical. But this is going to be in the realm of the standard normal distribution. So what we have here then, inside of here is 90%. So you know the area here. You're actually trying to figure out the z-value. And even when we do figure out the z-value, that's not the end of it. I've got to go back and do an anti-z equation to find this x value. So let's start first with this. Let's see if we can use the table to find a z-value that has 90% area to its left. So as you scroll through here, you're going to need the positive side because you can clearly see that the x and z when I wrote them are way off to the right. What you want to do in here is try to get as close to 90.90 that you can. Let me show you ones that I have here. These two guys right here. Oops. So here's what I have. The 90% is here. It's between these two values. It's somewhere in between there. So I've got 1.2 is the row, and then I've got 1.8 or 1.28 and 1.29. I personally don't mind if you use either value, but I'm going to use a different one. I'm going to use the average of those two values because I like mine to be a little more accurate. So I will have 1.285. So I will go to a third decimal place. That tells you what z is equal to. Now we have to undo the z equation. So we know that the formula for the z equation looks like this. Well, the z, I know what that is, 1.285. The x was, I don't know what that is. The mu was 750. And the sigma was 50. What I've been telling my students in class to do is to put a 1 underneath the decimal, and then you can solve this using cross multiplication. In fact, this cross multiplication is really simple because you're just multiplying by 1. It won't do anything. But the other side, you will have to multiply it out. So 1.285 times 50. And then to finish it off, you need to add 750 to both sides to get the value of x. That was the thing they actually wanted us to say. So that'll be 814.25. Now, since these are test scores, it's probably going to be the case that the numbers are whole numbers, and they would probably either say 814 or 815. Don't concern yourself with that. I'm happy enough that you just get to this point. That's a perfectly good answer for me. And so that is the score. There was a second part to it. Part B was what's the 75th percentile. So I'll redraw the picture, the original one. It had a mean of 750. The 75th percentile then is going to be a score that we don't know, but I do know that to the left of it is 75% of the data. So I'm going to go in the table, and you can tell that Z is going to be positive, but I'm going to go in the table and try to find 0.75 somewhere inside of it, in the interior of the table. So I need to be on the positive side. I see, here's our guys. I've encapsulated the two parts here. So we've got 0.67 and 8. So 0.67, 0.68. What I do is take the average, 0.675. And then our job then is to go backwards and get the X value. Remember, the Z is just a step before we get there. As you recall, Z equals 0.675. But Z also equals X minus mu over sigma. And I'll go do one more step. And I will solve it the same way I did before, using a cross multiplication. X, I don't know the value of it, but mu I knew to be 750, and sigma I knew to be 50. Cross multiply like you did before. We get X minus 750 equals 50 times 0.675. And then to finish this off, I'm going to add 750 to both sides. So this cutoff score for that is 783.75. Notice that number is less than the other one. The other one had a 90% is harder to accomplish. So those scores to accomplish those are higher, of course.